Hello dear students, welcome to mathematics class. So in this class, let us discuss some more examples on homogeneous equations. So to solve the homogeneous equation, we need to substitute x equal to e power z, z equal to log x, and x square d square y by dx square equal to d into d minus 1, and x into dy by dx equal to d, x cube d cube y by dx cube is d into d minus 1 into d minus 2, and so on. So here in the previous video we have discussed the examples when the RHS of the differential equation is 0, and now let us discuss when the RHS is other than 0, then how to solve the differential equation. We know that whenever RHS is non-zero, then the solution has contained two parts, one is complementary function and one is particular integral. So therefore let us start the examples. Now the first example is x square d square y by dx square plus 9 into x dy by dx plus 25y is equal to 50. So here RHS is non-zero value, that is 50. Now here substitute x equal to e power z and z equal to log x, and here x square d square y by dx square plus 9x dy by dx plus 25y. So this can be written as d into d minus 1 plus 9d plus 25, right, into y is equal to 50. Then after simplifying this, we got d square plus 8d plus 25 into y is equal to 50 into e power 0z, because we can find the particular integral when the RHS is of the form either e power z or x power m or sin ax cos ax or x power m into v or e power ax into v, right. So therefore here there is no standard form, so therefore we have written as e power 0 z. Now the auxiliary equation is m square plus 8m plus 25 equal to 0, and the complementary function of this one is e power minus 4z into c1 cos 3z plus c2 sin 3z. So it implies that here roots of this equation is minus 4 plus or minus 3i, which is the complex form or complex roots. So for that e power minus 4z c1 cos 3z plus c2 sin 3z, then it is x power minus 4 because e power z equal to x, and c1 cos 3 log x plus c2 sin 3 log x since z equal to log x. So already we have discussed how the complementary function will become a function of x from function of z. So therefore here this is the complementary function, and the particular integral is 1 divided by f of d into 50 e power 0 z. It is of the form e power ax. So whenever f of d e power ax is there, then just substitute d is equal to a. Here the value of a is equal to 0. So therefore this is equal to 50 divided by d equal to 0 plus 8 into 0 plus 25. It becomes 50 divided by 25, which is equal to 2. So therefore the complete solution is given by y is equal to cf plus pi. So here we know this is the complementary function and this is the particular integral. Just add those two to get the complete solution. Next example, x square into d square by dx square minus 2x dy by dx minus 4y is equal to x power 4. So here x equal to e power z, z equal to log x, all the substitutions will be same. So now the equation becomes d into d minus 1 minus 2d minus 4 into y equal to e power 4z, because x equal to what? E power z. Then here this becomes d square minus 3d minus 4 into y equal to e power 4z, and the complementary function for this equation is c1 e power 4z plus c2 e power minus z. Means here we have not written the auxiliary equation. Here the auxiliary equation is what? M square minus 3m minus 4 equal to 0. The roots are 4 and minus 1. Then it is c1 e power 4z. This 4z is x power 4 and e power minus z is x power minus 1. Then the particular integral is 1 by f of d e power ax. Whenever 1 by f of d e power ax is given, then just to substitute d is equal to a. So therefore it is 1 divided by 4 square, because a equal to 4, minus 3 into 4 minus 4 e power 4z, which is equal to 1 divided by 16 minus 12 minus 4 e power 4z, right? Now look at the denominator. So now here denominator is giving the value equal to 0. Then how to find? Now this becomes not defined, right? So therefore whenever, or this is called as case of failure, that you may remember, whenever the case of failure occurs, then we know that x divided by f dash of d into e power ax, right? Like that, here instead of x we are going to put z, because it is a function of z. Now here this becomes z divided by differentiation of this one is 2d minus 3 e power 4z, right? Then this is equal to z divided by 2 into 4 minus 3 e power 4z, and which is equal to z divided by 8 minus 3, that is 5 e power 4z. Then after getting the answer, we need to replace z by log x and e power 4z by x power 4. So therefore its answer is log x divided by 5 into x power 4. That is the required particular integral. Then y equal to cf plus pi. So be careful, whenever the case of failure occurs, then that is z divided by f dash of d, right? That is already solved in the third unit. Just remember those things to move further. Next example, x square d square by dx square minus 2y is equal to x square plus 1 by x. Now substitute x equal to e power z, z equal to log x, then the equation becomes d into d minus 1 minus 2 into y equal to, now the RHS, x square means e power 2z, 1 by x means e power minus z. So the auxiliary equation is m square minus m minus 2 equal to 0, roots are 2 and minus 1. Therefore the complementary function e power 2z plus e to e power minus z. So e power z equal to x, so that becomes x square and x power minus 1. This is the required complementary function. Now go for the particular integral. So particular integral equal to 1 divided by d square minus d minus 2 e power 2z plus e power minus z. So here we have two functions, then we need to split the denominator for each one. Then it is 1 divided by d square minus d minus 2 e power 2z plus 1 divided by d square minus d minus 2 into e power minus z. Now it is 1 by f of d e power ax, right? Now first check the denominator whether it is equal to 0 or non-zero for the value of a. So here a is equal to 2 means 4 minus 2 minus 2, that becomes 0, and here minus 1, this becomes plus 1 minus 2. So here also the value of the denominator is equal to 0. Otherwise here now d square minus d minus 2 for d equal to 2, that is 2 square minus 2 minus 2, that is 4 minus 4, which is equal to 0, and d square minus d minus 2 for d equal to minus 1. So minus 1 whole square minus of minus 1 minus 2, right? Then here this is 1, then minus of minus becomes plus 1 minus 2. This is 2 minus 2, which is equal to 0. Means for both the functions the denominator is 0, then we need to differentiate the denominator. Now z divided by 2d minus 1 e power 2z plus 1 divided by 2d minus 1 e power minus z. Now put the value of d. Z divided by 2 into 2 minus 1 e power 2z plus 2 into 2 minus 1, sorry 2 into minus 1 e power minus z. Here it is z divided by 2 into 2 4, so 4 minus 1 is 3, so z by 3 e power 2z plus 1 divided by minus 2 minus 1, so here not 1, z, so z divided by minus 3 e power minus z. So therefore here z equal to log x, so log x divided by 3 e power 2z is x square minus z by 3 e power minus z is x power minus 1, and here z equal to log x. So this is the particular integral. Then the complete solution is y is equal to cf plus pi, which is the required complete solution. Next example, x square d square by dx square plus 2x dy by dx minus 20y is equal to 1 plus x whole square, and this can be written as 1 plus x square plus 2x, that is a square plus b square plus 2ab form, and x equal to e power z, z equal to log x, the remaining substitutions will be same. And now simplify the LHS by substituting d into d minus 1 plus 2d minus 20. Now we got that as d square plus d minus 20 into y is equal to, here 1 is 1 and x square is e power 2z 2x, that is 2 e power z. Then the auxiliary equation is m square plus m minus 20 equal to 0, and the corresponding complementary function is c1 e power minus 5z plus c2 e power 4z, and the complementary function in terms of x is c1 x power minus 5 plus c2 x power 4. Then particular integral is 1 divided by d square plus d minus 20, the function 1 plus e power 2z plus 2 into e power z. So now here it is, we need to separate the denominator for each and every one. So 1 is e power 0z, here e power 2z, here e power z. Then for the first one d equal to 0, so 0, this is also 0, then remaining 1 by 20, that is minus 1 by 20, and e power 0z is 1 plus 1 divided by, here d equal to 2, that is 4 plus 2, that becomes 6, 6 minus 20 is minus 14 into e power 2z plus 2 divided by, here d equal to 1, so 1 plus 1 minus 20, so 1 plus 1 is 2, then 2 minus 20 is minus 18 e power z. So therefore it is minus 1 by 20 minus 1 by 14. Now e power 2z is equal to what? X square plus, sorry, here 2 divided by minus 18 is there, that is minus 1 divided by 9 e power z is x. So this is the particular integral. Then add the complementary function and particular integral to get the complete solution. So therefore y equal to cf plus pi. Next example, x into d cube y by dx cube plus d square y by dx square is equal to 1 by x. So now look at the problem. It is not in the standard form, means whenever or the coefficient of the derivative, means d cube y by dx cube or d square y by dx square, that must be multiplied by the same order of x. But here it is x, this should be x cube, and here we must have x square, but there is no that x square. So therefore we need to multiply the equation by x square, then that will become x cube d cube y by dx cube plus x square d square y by dx square is equal to x. Now that becomes the standard form. And now substitute x equal to e power z, z equal to log x. So now substituting all those things, this x cube d cube y by dx cube becomes d into d minus 1 into d minus 2, and this is d into d minus 1 is equal to e power z. Then after simplifying this one, that is d cube minus 2d plus d into y equal to e power z, and the auxiliary equation is this one. Complementary function is c1 e power 0z plus c2 plus c3 z e power z, means the roots of this are 0, 1, 1. 1 is repeated twice, so therefore c2 plus c3 z e power z. Now z equal to x, here e power 0z is 1, that is c1 only, then c2 plus c3 z equal to log x and e power z equal to x. So this is the complementary function. Now the particular integral is 1 divided by d cube minus 2d plus d e power z, where z equal to 1. So now check the value of the denominator for d equal to 1. Here we have d cube minus 2d plus d, right? For d equal to 1 means 1 minus 2 plus 1, which is equal to 0. So therefore now the particular integral becomes z divided by differential of this one, 3 d square minus 2 plus 1, right? 3d square, here 2d is there, that means 2 and differential of d is 1. Now it is d power z, which is equal to z divided by 3d square minus 1 e power z, right? Now so here this is not 2d, 2d square, this is 2m square. Here d cube minus 2d square plus d, and this is 2d square, then here its derivative is 4d. So here this is equal to z divided by, this is 3d square minus 4d plus 1 e power z. Now here denominator is this one. Now again check the denominator for z, d equal to 1. Here 3d square minus 4d plus 1 is equal to 3 minus 4 plus 1 is equal to 0. Again it is 0, means now this becomes z square divided by, again differentiation, that is 6d minus 4 e power z. Then this is equal to z square. Now d equal to 1, that is 6 minus 4 e power z. So 6 minus 4 is 2, z square divided by 2 e power z, which is equal to log x whole square divided by 2 x. E power z equal to x and z equal to log x. So this is the particular integral required. Then write the complete solution y equal to cf plus pi.